So with this question, we have the integral of 8 over 1 plus x squared between 1 over square root 3 and square root 3. So the very first thing that I'm looking at here is my integrand. I don't really like to integrate questions that are in ratio form. Typically you want to integrate questions that are in polynomial form, either a monomial or binomial, trinomial, some group of terms that are all separated by plus and minus signs. Ratios are not usually going to give you some good results. Luckily here I do kind of remember that there is a special integral, let's write it here off to the side, that says that the integral of 1 over 1 plus x squared dx, of course, is actually equal to the tangent inverse of x. So it looks like I'll be able to get this question to look like this over here, which I know to be true simply by memorization. So what I'll probably do is put up a video or a screenshot that shows this particular integral, and then there's a lot of other ones as well that you should always look out for and see if there's some type of pattern from your question that can match up with one of those special integral questions that makes your life a lot easier. So in this case, how do we get this to look like that? Let's go for it. So I can pull out the coefficient 8, the constant 8 in front of the integral, and what I will be left with, my root 3 and root 3 here, would be 1 over 1 plus x squared, right? Because 8 times that is that, so really I'm already to where I want to be. So like I said before, this is equal to tan inverse x. So what I have here is 8, and then 8 is going to get multiplied by the tan inverse of x between root 3 and 1 over root 3. So like with any other time that we integrate, once we find the antiderivative here, which is a tan inverse x, we simply plug in our limits of integration. So I have my 8, so that's not going anywhere, but I'm going to put tan inverse inside parentheses, and I'm replacing x this time with square root 3. And then I'm subtracting away from that tan inverse of 1 over square root 3. Alright, so let's see what that is. So square root 3, right? So for tangent questions, we have our tangent wave at our disposal, which hopefully you remember looks something like this, or this is 0 and this is pi over 2, and basically every pi over 2 you have asymptotes. But then also we can use our right triangles, and it looks like right triangles are going to be what I want to use for this case, because I remember that my 30, 60, 90 right triangle has a square root 3 in it. So the side opposite of 60 is square root 3. The side opposite of 30 is 1. The hypotenuse is 2. Let's put my 90-degree angle there. And I remember from SOHCAHTOA, let's write that down. I remember from SOHCAHTOA that tangent is opposite over adjacent. So where would I have opposite over adjacent equaling square root 3? Well, that would be 60 degrees, right? The opposite of 60 is square root 3. Over the adjacent to 60 is 1, and 60 as in radian measure is pi over 3. So the tan inverse of square root 3 would either be 60 degrees, or we're going to call it pi over 3. The same thing now with this here. Where would I get 1 over 3? Well, that would be the opposite of 30 over the adjacent, so that would be pi over 6. And I still have my 8 outside. So I can simplify what's in the brackets first. Pi over 3 minus pi over 6, get the same denominator, would be the same as 2 pi over 6 minus pi over 6, which is equal to pi over 6. You multiply that by 8, and you get 8 pi over 6, which can be reduced by 2, so you get 4 pi over 3. And that would be your final answer.